So, hello everyone, welcome back, and I'm very grateful that I am very back. And what you can see here, this is my Jetson Nano. I want us to revive it with you, then we can be able to run some tiny machine learning workloads over it and make things spicy for that matter. So, stick with me. This is my small bench work area. There are very few tools. So, as you can see, when actually I was using this Jetson Nano, I had some time to create all these things that you can see. This is just an holder that I custom made myself. Okay. Quite interesting one because I didn't have a special sort of casing. And then I hand to make this particular power supply, which actually incorporates some sort of power regulation, and it also has got some temperature controls. This must have been an Atmega chip, or Atmel chip for that matter. And what it was doing, or what it should be doing after this, when the temperature reaches some threshold, that is temperature of this particular hardware, that's Jetson Nano, then the expectation is it shouldn't go to this color, and then if it's too high, it shouldn't go red, and of course increase the cooling or the RPM of this particular fan. So let's disassemble it. We clean it up. I already have some tools here. It's a foam cleaner, it's a general foam cleaner. And I also have some few brushes that I'm going to be using to clean this up. So this is a normal generic fan, which is actually a 12 volts 0.45 amperes. This is a fan. And then because I'm using a DC to DC converter, this one over here, it's a very common module that uses this LM2596S DC to DC converter. It can take 12 volts or 18 volts, transform it to around 12 volts, at 5 volts for that matter. And then the still laugh on me, I was using an external temperature. I know you have interesting recommendations. This is a temperature sensor that I was using. Interestingly, you come to realize that this particular sensor was inserting it here and manually measuring the temperature of this heatsink. And whenever its temperature could go to a particular threshold, of course I could light this fan. Of course, everything controlled in this simple circuits here. And let's see if we can develop this thing. I hope I'll remember the password, especially for my Jetson Nano. It has been a minute since the last time I used it. So other tools that I have here, this is a digital multimeter. Most of you already know what this is. It's a basic tool for engineers. I have not retired. I'm just getting started. I just hope the knowledge that I have, I'm going to transfer it to you guys. You'll see how you're going to run some interesting AI workloads in this particular board. It's called Jetson Nano. Most of you already know it. It's quite an interesting, powerful board. And let's start cleaning. So I've already removed what was up here. So the next thing I want to do, I want to just do some very serious cleanup on this particular hardware. I'm going to remove the processor. In fact, this is the entire processor. To me, it seems very clean. Yeah, as you can see, I was using a memory card 64 GB, which was already there. So this is the heatsink. This is the heatsink. Then this is the processor. This is the thing that carries the GPUs and other things. We're going to see, of course, the properties of this particular NVIDIA Jetson Nano GPU. So this is the board itself, the Jetson Nano itself. So one thing for sure, if you remember your electronics 102, yes, not 101, 102, you must have learned some basics whereby you should not touch these active components directly for obvious reasons, and one of them being they are very sensitive to electrostatics. And what that means is that in case this particular capacitor is charged, then and we have an active component in this particular hardware, you might see smoke. And you know smoke is always a factor of the Ohm's law. You guys remember Ohm's law? Yeah, you do a short circuit, current shoots, and then stuff start smoking. Yeah, so you don't want to get there. So if you have any hardware, actually you have to be very careful while cleaning it. Then you realize these capacitors and resistors are very small, so you have also to be very keen while doing the cleaning, because in case you use a very rough brush, you might ruin your board. So those are some of the things also you must consider while doing your cleaning. So guys, as you can see, you're getting somewhere. And my many apologies actually. I'm doing this video on an evening after the job. Because after day job there's some exhaustion. But I know if you love electronics and you love to see new things, you will enjoy this. So this is the hardware itself. It's quite clean. Then the next thing, I want to clean up this particular board, the one that is holding our hardware, and I also want to clean the power, the heat regulation board. Okay. In fact, I think one of the interesting one is the fan. You can either do a full cleanup or a partial cleanup. Here we are going to do partial cleanup because of time and resources. Remember to never put this particular form to active components like your actual Jetson Nano or your active components in any hardware. Okay, it may be a laptop, it may be a mobile phone. Laptops, you can wash your casings or your external covers, but not your internal part. That is can cause serious problem over your own machines. So I'll pause and complete cleaning, then we get back. So I'm done with the cleanup of the fan. Actually, I did a partial cleanup. This cleanup is whereby I didn't remove the blades themselves. These are fan blades. As you can see, it's quite clean, better than before. And also my hardware is clean. So what is next now is to clean my holder. So actually I'm done with the cleanup. As you can see, my holder is clean, at least better than before. So it's time again to assemble my Jetson Nano, and we're going to start with the mother himself, or what many people can call the motherboard. This is the GPU itself actually. To install it is quite easy. That's that. Fortunately, I didn't have enough screws to screw it in, but I know it will work seamlessly. So we are done with the assembly. Actually, it didn't take much time. The next thing, we need a power supply. So I hand this one of my own power supplies. We have to use our digital multimeter to ascertain the polarity of the port. So I'm going to put it on. Then I'm going to use the DC of 20. I want to measure and affirm that it is 12 volts. Of course, it's given it 12 volts. That's the rating of the adapter. So it's 12 volts. And just wanting to be sure of which one is positive, because in case you reverse, then it won't cause problems. So again, electronics 102. That is not on 1. Always ensure your multimeter or your multimeter, the positive one is in B and the common is, of course, the ground one or black one is in common, to make sure you don't mix things up. So I already know my positive one is this, so I'm going to close this like that, and then I want to measure the continuity of my positive terminal. So electronics 101, the internal one is the positive for this case, so I can confirm that this is again the positive one. I need a tape. I have a tape nearby here, so I needed a black tape. And I'm realizing my tape could be far for the sake of this, but oh no, it's somewhere here. You can see it somewhere. I didn't get the black tape. For now, I'm going to use this office white tape. I'm going to replace it later. So let's tape it. So I'm done applying the tape. So as you can see, this is my positive inside here and negative here. So, and as you can see over here, it's 12 point something volts. Okay, next thing, I need to power my regulator. So the expectation is very simple. This is like a temperature. It's a temperature. In fact, it's a temperature regulator. So the temperature is room temperature. It should be green. When the temperature is so high in the heatsink, it turns this other color, and when it is so high, it turns red. It's like a pulse width modulation. And then what usually happens is when it's too high, it turns red. This particular fan increases the RPM, it cools down, it returns back here, and the cycle repeats depending on the LLM you are running in this hardware. So that is That is the architecture that actually I designed this thing on. Quite simple, but of course when you put it on, you expect it to run. So this one will always run at a certain RPM, as you can see. Don't know if you can see that. Yes, so it is running on a certain RPM, and it is green, so that means it's normal. Yeah, when the temperatures rise to some level, it will increase the speed, and things go like that. Moments of truth. I want to put on my Jetson Nano, this particular guy here, spice things up, and then see if it's still alive, or we have wasted our 10 minutes trying to wake him up. So I need a power supply which can give me at least 3 amperes, 5 volts. That's the rating of this particular hardware. So give me some time. I need to fetch my 5 volts 3.1 ampere power supply, which is again connected to my Raspberry Pi 5. So I have brought my adapter. It is a Type-C adapter, as you can see. Interestingly, it's a very powerful adapter. I don't know if you can see the ratings, but it's not even as I thought. It is 5 ampere maximum and 5.1 volts, that's output. And also it can give 9.0 volts at 3.0 ampere. So that's quite a huge power. Again, electronics 103. The power for this particular adapter, the power output, if you consider 9 volts and 3 ampere, power equals current multiplied by the voltage, then that is 27 watts. Quite some power there. And if you look at the other output, which can be 5.1 volts at 5.0 ampere, that's close to 25.5 watts. Yeah, quite some power there. So what I'm going to do, I'm going to switch off my power from the major source. Okay, right. In fact, this one doesn't mean anything, so it can remain as it is. And then just going to power on my Jetson Nano. Here we go. So this is the power source. It is green here. Don't know if you can see a small light over here. So what I'm gonna do next, I need to connect to my keyboard, an external keyboard. I'm going to put it here. Let me see if it's getting on. The next thing I want to do is simple. I need a monitor, so I need a cable that runs all the way to that particular place. So let me pick one HDMI cable and bring it. Let me rub an HDMI cable and bring it up. So I got some HDMI. It's here. Actually, it's quite short. Going on. From what I'm seeing, let's select HDMI 3. The temperature has gone high, so it could be it's already on, because you can see the temperature has changed to yes. So my Jetson Nano is going on. I'm not so sure why it's not going on, but it has been a minute since the last time this particular hardware was used. Okay, it seems like this OS was corrupted. What do you think, guys? Yeah, just think we're heading in the right direction. So I later realized that this particular memory card that I was using, which is a SanDisk 64 GB memory card, had some issues. So I had to purchase another one. Unfortunately, I could not purchase a SanDisk again. It's called Boost, which is 128 GB. This time around I had to buy a bigger one. It cost around 3,000 Kenyan shillings. That's equivalent to around $25 for that matter, or around $30. And I don't know if this is gonna work. I've already done my dues, that is burning the operating system in it. So I'm gonna power it on with my power supply and see the reaction and see how this goes. So here we go. That's the power supply. Let's see if it's going to wake up. Let's give it some time. Then obviously it is going to do its thing. So it seems like it's actually installed successfully. And seems like I require a mouse, so I'm going to use a wireless mouse. This one over here. This is my doggo, so I'm going to insert it here, and then to enable me select. I don't know if this is operational. Yes. So this is a setup actually. So English is my language of choice. So I am in Nairobi, Kenya. So I'm going to choose, for the purposes of time zone, I'm in Nairobi. Nairobi is not coming up. Let me try Kenya. Kenya time. Yes, this one. So I'm here, East Africa. That's Kenyan time. Go next. Your name, you can call it Aaron. Aaron. And then, so I'm going to pause here to make sure that, so I'm done setting my password. And I actually set a very simple password. As you can see, it's 1, 2, 3, 4, 5, 6, 7 characters. I want to log in automatically. This is just a learning kit. What is this? Please enter design size of app partition. I don't think there's any need of partitioning this, so I'm just gonna continue. And then, yes, I intend to use this for my LLMs and other things for deep learning purposes. So I'm gonna create a swap file. So continue. I'm gonna keep it default. The setting can be changed at runtime using NVP model GUI or NVP model command line. So let's continue. So configuration takes some time. So I'm gonna pause here and come back whenever it's done. So the configurations are actually almost done. So if you have any Jetson Nano, or you're also using maybe say Raspberry Pi 5, you have to ensure that your Raspberry Pi is with, or the Jetson Nano is with a very powerful power supply, because again, power supply here is everything. It requires to have at least 3 amperes stable. Remember, mine has got 5 amperes, so it's quite stable. So I'm done installing. I want us now to install some basic libraries. And in this current age, you don't have to reinvent a wheel, with all honesty. Yeah, you just don't have to reinvent a wheel. These things have been done before. All you need to do is connect your device to the internet. Yeah, so I want to check if it has wireless capability. Where is it? Let me see. It should be somewhere here. So this is the Ethernet device not managed, the network. I want to connect it to wireless. Edit connection settings. Let me see. So allow me to pause and check those particular settings, and I'll be back shortly. So after the thorough checks, the Jetson Nano that I have actually doesn't connect to Wi-Fi directly, and I'm gonna try this. The good thing is I have a number of things in my workshop, so I'm going to try this particular thing. It's an Wi-Fi broadcasting doggo, and see if this is going to work. So I'm gonna just have to put it here and then see if we will get wireless Wi-Fi. In fact, I think we have it. They are already now showing. As you can see, immediately after plugging it in, we have different Wi-Fi being broadcasted. So we are in, and I think the next video now is I want us to run a few projects. This is going to be project based. I have a camera, so some computer vision projects. I think I will have to purchase a microphone for us to be able to conduct some audio processing, and also see if we can process some NLP based projects in this particular Jetson Nano. So thank you so much. Actually, we are going to go. As you can see, this thing can play even music. It's quite a powerful board. Specs for Jetson Nano. It's quite a very powerful board actually. Let's see here the specifications for this hardware. As you can see, it's actually not hanging up. So this is the hardware that I was mentioning about. It's like the motherboard of this board. So it's small, very powerful computer for embedded applications and embedded AI IoT applications that delivers strongly powerful modern AI. And they are saying it's small. As you can see, it's quite small. Just disregard what I have built to support my hardware, but it's quite small. So it has got GPU, 128 NVIDIA CUDA cores. Also saying it has a quad-core ARM Cortex-1 A57MP core processor, 4GB 64-bit LPDDR4, 1600 MHz, 25.6 gigabits per second, storage 16GB, eMMC 5.1. It can process 1080p videos. Yeah, quite impressive. And also can handle this sort of cameras, connectivity, gigabytes, display, HDMI 2.0, USB. It has 4x. So as you can see down here, it has 4 USBs, which are 3.0, and 1 USB, which is 2.0. Again, quite impressive. This hardware also support GPOs. So we'll be seeing what those things are, but right here, there are some pins. They're called general purpose inputs and output pins, which support what you have seen, embedded AI aspect. And also it has got them I2C, LTC protocols, I2S protocols, SPI, UART protocols, which means you can communicate with many sensors. So I think the strength of this Jetson Nano is this powerful compute module, the one with heatsink. I showed it in the starting of this video, which has got 1.8 NVIDIA CUDA cores. Yeah, so this is quite powerful. So in the next videos, I think we're going to do project based. Yeah, they are going to be project based, and I hope you're going to like this. Should I appear in the video today? Adios.